The last thing we need to talk about in this unit is how to solve a log equation. And to solve a log equation, we're going to use the inverse of logarithms, which is an exponential function. The first thing that we need to do is have the logarithm so that it's by itself on one side of the equation. In both of the first two examples, that's true for us already. Once you do that, we're going to rewrite it in exponential form, just like the first day when we learned the definition of a log. So this is where we use the kind of loop method, where I change this to mean that 3 to the fourth equals 2x minus 1. At this point, we just use our calculator to do some arithmetic. So 3 to the fourth is 81 equals 2x minus 1, and we have those familiar two-step equations to solve. So add 1 and divide by 2. So x equals 41. Look at the next problem. So on the next problem, what's missing? We're missing the base. So if I have the word log and it's missing a base, what's the base supposed to be? 10. So I'm going to add the 10 there. So it's really a base of 10. So we can rewrite this as saying 10 cubed equals 2x plus 5. And 10 cubed is just 1,000. So 1,000 equals 2x plus 5. Subtract 5. And divide by 2. So x is 497.5. Oh no, we're missing a base in the next one. Please stop saying ln. I hear so many ln's going on in the classroom. Natural log, y'all, natural log. So it might help if I rewrote it as what ln really stands for, which is log base e of 3x plus 2 equals 5. So ln, natural log, just means log base e. So what we're going to do is do e to the fifth equals 3x plus 2. And if you look on your calculator, the e to the x button is right above ln, natural log, on your calculator. So e to the fifth, and we're going to keep it to at least 3 or 4 decimals when we're doing this, and then we're doing 2 decimals at the end. So 148.4132. And in this unit in particular, it's really helpful to use that second answer, to just keep using the answer so that we're keeping our answers as accurate as possible. So we're going to minus 2 and then divide by 3. So 146 point my beautiful decimal. So divide by 3, and x equals 48.80. Okay. Now, this next one is so tempting. What is so tempting? It is so tempting to do 4 minus 5 is negative 1. Please do not fall into temptation. No. A log is like a variable in the sense that it makes it not like terms. So I cannot combine those. What I want to do, though, is get this log by itself. So sometimes it can help to kind of blob it or box it up. And then I'm trying to get that whole blob by itself. So I'm going to subtract 4 from both sides. And then my next step is going to be to divide by negative 5. You better bet that there's going to be a question like this on your test, and it's there to see if you will fall into that temptation of combining the 4 minus 5. Okay, so divide by negative 5, and we get log base 3 x plus 5 equals 4. And then we rewrite that in exponential form, so 3 to the fourth equals x plus 5. Man, I really liked 3 to the fourth on these problems. So we said already that was 81, and subtract 5. So x equals 76. Okay, our last solving one looks a little bit different. One thing I noticed is that I have 3 logs going on, and the other is I have a lot of x's. So what we're going to have to do here is we're going to have to use our log properties. So if I have addition between 2 logs of the same base, that means that I can rewrite them as a single logarithm, aka condense them, and combine their arguments by multiplication. Remember, these are just the inverses of our exponent rules. Equals, whoops, lost my 2 natural log of x. The other thing we can do is bring in that 2 on the right-hand side as an x squared. So I'm just going to write that. Natural log of x squared. And you can FOIL all this stuff out. So we get 2x squared minus 3x minus 4x, so minus 7x plus 6. And since I have the same logs on both sides, that means you can set their arguments, that's the inside, equal to each other. So 2x squared minus 7x plus 6 equals x squared. And this is going to be a solve by factoring problem at this point. So I'm going to subtract x squared from both sides. And now factor. So you can use the x or whatever it is you use to factor. At this point in life, hopefully it's getting a little bit easier to guess and check. And now that means one of these 2 things has to be 0, so either x equals 6 or x equals 1. Now, with logarithms, we can sometimes get extraneous solutions. That means there are extra solutions that don't work in my original equations. So what we have to do is we have to substitute in and make sure we don't get something invalid in my argument. So I'm going to substitute in 6 first. So here I would have 6 minus 2, which is 4. That's fine. Whoops, that's a 4, y'all. Whoop. Here I would have 2 times 6 minus 3. That's fine. 6 is fine. Okay, basically we're looking for anything less than 0. That is going to be impossible when we talked about what the definition of a log is. And now let's try substituting in 1. So if I do 1, I'm going to have 1 minus 2 is negative 1, which I can't have in my argument. So that means my only solution is not this, is not the 6 and the 1, but just the 6. So only one solution. The last thing we need to talk about is finding inverses. So it's the same idea as finding the inverse of an exponential. We're just going the other direction. So we need to get our logarithm term by itself. So after we switch x and y, I think y'all are already pretty fast at that step. So we'll subtract the 7. So x minus 7 equals log base 4 of 5y minus 3. And now it may look a little weird because this is kind of the opposite side of how we've been writing stuff. But we're going to rewrite that in exponential form. So my base is 4. My exponent is x minus 7 equals 5y minus 3. So 4 to the x minus 7 equals 5y minus 3. All right, now we just need to solve for y. Add 3 to both sides, and then we will divide by 5. So I'm going to go back up to the top. 4 to the x minus 7 plus 3 equals 5y, and then divide by 5. So you can leave it as that big fraction, or we could also just simplify that as 1/5 times 4 to the x minus 7 plus 3/5 equals y. Or once again, we could just leave it as this kind of giant ugly fraction. That's it to logarithms.